All right, let's take a look at the integral of tangent of x dx. So we're right now on this track to look at integrals that you have to first do some kind of algebraic manipulation in order to get going. I guess this you'd call maybe more a trig manipulation, but you can rewrite tangent of x, of course, right, as sine of x over cosine of x. Okay. No change here other than just a bit of trigonometry. Really, I think the only choices for u would be either sine of x or maybe u is equal to cosine of x. One or the other. It's, you take your pick, maybe make a guess. The thing is, if you chose u to be sine of x, the thing that I think will end up going wrong here is, well, you get du is equal to cosine of x, but then the problem is that this cosine of x appears in the denominator. So this doesn't seem to be a choice that's going to work out well. If, on the other hand, you picked u is equal to cosine of x, then you're going to compute du is sine of x. Well, there's a minus sign, but the minus sign doesn't really bother us. But the point is, you'll get this sine of x that's in the numerator. You're going to have to just really try this out on your own to see why this doesn't work. But this u is equal to sine of x doesn't work. Maybe if there's time, I'll sort of show why at the end of the video. All right, so let's take this u is equal to cosine of x that's right here. If you differentiate, you'll have du is equal to negative sine of x dx. All right, so then you can take the integral that we have here and rewrite this. Maybe we'll write this as, first just rewrite this for now as 1 over cosine of x. Then you have, maybe we'll write that as negative 1, so that there's now also this negative sine of x dx. So the two minus signs that have been introduced will cancel each other out, so that what's written here and what's written here are actually equal. But the whole point of introducing those minus signs is, well, now this negative sine of x dx is exactly du right there. Okay, so now if we do some replacements, this is integral negative 1 over, then you have this cosine of x there. We'll replace that with a u. Then you have this negative sine of x dx. That's right there. We're going to replace it with a du. Okay, that's now a nice looking integral. Okay, so this, don't worry about the minus sign. We'll just bring that in front first using the constant multiple rule. Now we're just anti-differentiating 1 over u, and that's ln of absolute value of u plus c. The last thing to do here is just to replace the u, which appears right there, using this u is equal to cosine of x. So if we do that, now we have this negative ln absolute value, and now this is where u comes in. This is cosine of x, and then finish off this absolute value side, and you have a plus c there. All right, so maybe I will take a moment to just talk about what happened if you chose u is equal to sine of x. Let's just give that a try. Okay, so I think I have space for that down here. All right, so let's try this. So I don't think this will work, but if you chose u is equal to sine of x, well then du, you have to ignore all of the rest of this work. Right? None of this counts right now. But if you look at du, now you get cosine of x here, dx. Okay, no problem. Now let's go back to the integral itself and try to rewrite this. Let's do like the same thing we did over here to try to separate out this fraction into two pieces. So the integral that's right there, if you rewrite this, this will be integral 1 over cosine of x, then maybe sine of x there, and then dx. Now we're on the hunt for an expression that says cosine of x dx. We don't have that. We have the dx part, but we don't have cosine of x. Well, there's a cosine of x in the denominator, but that doesn't help us out here, right? You could do something like, I guess maybe a 1, you could multiply by cosine of x over cosine of x, so that'll actually give you a cosine squared of x in the denominator. Then you have sine of x, and then the cosine of x, which we introduced in the numerator dx, and you do that all just to get this cosine of x dx to line up with the du. But now, if you do that, then fine, this part gets replaced, but the rest of this right here, well, what happens to that? So this I think turns into a bit of a mess, and yes, you could replace the sine of x with a u, But even if you did that, you still have this extra 1 over cosine squared x to deal with, and that just doesn't end up going away. So it looks like u is equal to sine of x is not going to work.